All right, this is a video tutorial on 3.1 pairs of lines and angles in the Big Idea Geometry textbook. Your three learning objectives are you can identify lines and planes, identify parallel and perpendicular lines, and identify the pairs of angles that are formed by transversals. So first major thing we need to kind of review, and maybe one thing will be new, is parallel and skew lines. Parallel lines are any two lines that are coplanar and do not intersect, so they don't cross, but they are on the same plane, on the same level. Skew lines do not do either of those, so they are not coplanar and they do not intersect, so they are not on the same plane. They could be on the top and the bottom of a three-dimensional shape or the top and the left of a three-dimensional shape, but they're not on the same level and they don't touch each other. Then parallel planes are whole planes that don't touch each other. So think of the top of the box, the top and the bottom of a Kleenex box, or the left and the right of a Kleenex box. They're the planes that don't touch each other. So this is a diagram that has all three of those examples present. You have lines M and N that are on the same plane and they are parallel to each other. Those red arrows on M and N help you indicate that they are parallel. Then the two vertical lines between them, right here, is the symbol for parallel. Then you have lines M and K that are skew. Notice how M is different than N. M is not touching K, and K is vertical, going up and down through those two planes. Those two lines are skew. N and K are not skew because they are intersecting. There is a point where it crosses between them. So you cannot say that N and K are skew. You can say that M and K are skew. Planes T and U are parallel. Again, you're using capital letters to designate a plane, and those planes are not touching each other. And again, I talked about earlier that K and N are intersecting, so you cannot say that they are skew or parallel. Okay, think of each segment in a figure as part of a line. Which lines or planes appear to fit the description? So part A, any lines that are parallel to CD and contain the point A. So in order for two lines to be parallel, they must be on the same plane. Well, there are two different planes that make up CD. You have that top of a three-dimensional shape and the left of the three-dimensional shape. But in order for that to also contain point A, it must be on the top of the plane. So AB is the only one that contains the point A and is parallel to CD. You could also say that HG is parallel because it's going the same direction in EF. However, they do not contain the point A, so you can only say AB. Okay, part B, lines skew to CD and containing the point A. Okay, so in order for your options to have skew lines, AG is not on the same plane and is not parallel. AH is not on the same line and parallel, or not parallel, to CD, and it contains the point A. So notice how that green arrow is not facing the same direction as your purple. And then if I move it to AH, again, not facing the same direction. There are a bunch of other lines that are skew in this diagram, but in order for them to contain point A, those are your only two options. Part C, lines that are perpendicular to CD and contain point A. Remember, in order for two lines to be perpendicular, you have to see a right angle or you have to see a red box on this diagram. So perpendicular lines to CD would be BC, AD, DE, and FC. But how many of those contain the point A? Would only be line AD is your only option. Part D, planes that are parallel to plane EFG and containing the point A. So EFG is your bottom, or that purple highlighted plane, and there is only one plane that is parallel to that, and that would be the top of the three-dimensional shape, so plane ABC, and it also contains the point A. Okay, two more postulates. Is pretty much just says if there is a line and a point not on the line, then there is exactly one line through that point and parallel to the given line. So you have your line L, that horizontal line, and a separate point P. There is only one line exists that through that point P and parallel to line L. Same thing if you think about it in terms of being perpendicular. If you have a line L and point P, there is only one line that is perpendicular through that point P that exists. You cannot have multiple lines through that point and also be perpendicular. Okay, so this example is looking at a city street grid, and you have given line markings to show how the roads in this town are related to one another. So part A, name a pair of parallel lines. Part B, name a pair of perpendicular lines. And part C is line FE perpendicular to line AC, I think is what that symbol means. Part A. So looking at these two arrows on your parallel lines, line AD has two of these arrow symbols. If you see any two on another pair, then that is going to be a parallel line to that first line. So if I highlight line AD with those two markings, line EF is also going to have those two markings. So that is a pair of parallel lines. Okay, MD and EF. So it looks like that symbol is meaning parallel in this example. Okay, now we're going to look at a pair of perpendicular lines. Again, in order for lines to be perpendicular, you have to see that 90 degrees or that red box at the point of intersection. So it looks like line AD or MD, depending on which point you're going through. And BM or BF is perpendicular to that, because you see that right angle box right there. And then part C is FE parallel to AC. Well, there's AC right there. It's that diagonal line that is going in a different direction. So no, it is not parallel, because they do not either have those markings or they are actually intersecting. So you can prove that they're not. All right, this is a major concept for the rest of this chapter. You're going to hear this word a lot. So a transversal. So a transversal is a line that intersects two or more coplanar lines at different points. The first word you're probably going to think of when you see the diagrams is a diagonal. It is not always a diagonal depending on how the diagram is set up. Just think of it as one line that crosses two or other lines. Okay, so in these examples right here, line T is your transversal. The other two lines are your coplanars. Notice how none of these lines are parallel. Okay, that line T in this first example, that's going kind of almost straight up and down, and then you have your first line that's almost flat, but the second line, if I continue going up, it will intersect eventually. That's okay. There may be some instances where they can be parallel, but they don't have to be parallel. And what we're going to look at first is just what happens at the point of intersection between your transversal and other angles. So anytime this line crosses two transversals, you're going to have four angles at this point of intersection. You can have 1, 2, 3, 4, and then same thing down here, 5, 6, 7, 8. So those are the numbers that you're going to be seeing through here. 8 different angles get formed by these examples. 2 angles that are corresponding are when they have the same facing position between your transversals. So 2 is in the upper right-hand corner of this intersection. 6 is also in the upper right-hand corner of this intersection. You could also be looking at another different pair. You have angle 1 up here in the upper left-hand corner, and then you have angle 5 up here in the upper left-hand corner. there are multiple different corresponding angles. It is not just 2 and 6. So corresponding is in the same position. So upper left, lower right, lower right. Alternate interior angles. So they are, let me go back. Alternate interior angles are when they are between your 2 lines, but on different sides of the transversal. So between your 2 lines means in your transversal, they are between those 2 red lines. So anything on the inside of those 2 red lines would be considered interior. And then on your transversal, alternate means that they have to be on opposite sides. So notice how 4 is on the right-hand side and 5 is on the left-hand side. Those are alternate interior angles. You could also have this angle to that angle as your other pair of alternate interior angles, and that would be 3 and 6, just for the numbering purposes. But they're all on the inside, and they just have to be on the opposite side of the transversal. Alternate exterior, again, is the same thing. So you're looking at lines or angles that are on the outside of your transversal. So anything up here above the top line and anything down here below the bottom line would be exterior. And then alternate would be anything on opposite sides of this transversal right here. So 1 and 8 would be an example. The other one that you could do would be this angle, and that angle right there is a pair of alternate exterior angles. Last one we're going to go through is consecutive interior angles. Consecutive just means back to back. So for this example, they are on the same side of the transversal. So interior, we're looking at things that are on the inside. That was not the straight line option. Inside of that line. And then anything that is next to each other on the example. So 3 and 5 are on the same side of the transversal. Your other option would be those 2 right there, consecutive interior angles. Okay, identify all pairs of angles of the given type. So again, you have 2 lines that are being intersected by a transversal. So we need to figure out which ones are corresponding: alternate interior, alternate exterior, and consecutive interior. Well, it'd be nice first to identify which one the transversal is. So that transversal is going to be this line right here. Okay, so that's our T. That's our transversal. That's our T. So anything that is in the same position would be considered corresponding. So position-wise, in the upper left-hand corner of both points of intersection would be angles 1 and 5. Then we can go in the same way, going in the upper right-hand corner. You have 2 and 6. Then the lower left-hand corner would be 3 and 7. And the lower right-hand corner would be 4 and 8. So there are 4 pairs of corresponding angles in this example. Now we're looking at alternate interior angles. So again, we're looking at angles that are on the inside of our 2 lines that are being intersected. So 2 is on the top of our transversal, 7 is on the bottom of the transversal. Again, remember that they are between your 2 lines, so on the inside, not on the outside. Then the other pair of angles would be 4 and 5, because 4 and 5 are both on the inside, but they are opposite. 1 is on top, 1 is on bottom. And again, you can't say 2 and 4 because those are next to each other on the same line. You have to pick different lines. Alternate exterior, same thing. We're going to be looking at angles that are on the outside of our intersecting points. So our options are going to be this, 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 and this are the only ones that can be considered exteriors. So 1 is above the transversal and 8 is below the transversal. So those are the pairs of alternate exterior. And the other one would be 3 and 6, because 3 is below, 6 is above. Now consecutive interior. We're going back to our options for interior would be here, 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 and here, because those are on the insides. And then consecutive just means they are on the same side of the transversal. So 2 and 5 would be together for the first one, and 4 and 7 would be together for the last one. And that is the end of the video.